So there it goes. Section 2.2 is actually a fairly beefy section. There's a lot of material in it. In the normal classroom, we would split it up over 2 days. So it has lots of parts to it. And the homework is split up over 2 different sections. So this is the beginning of section 2.2. I'll let you know when you finish the parts for that first assignment when we get there. So what we're going to look at now is an alternative way of solving the systems of equations. So we know that you can use substitution and we know that we can do elimination, but when we get to 3 equations or even 4 equations and 4 variables, that method is very cumbersome. You're likely to make mistakes. We need something a lot more usable and user-friendly. So what we're going to do in this section is something called a new method. It's called the Gauss-Jordan. So we're going to use the Gauss, that's a G, Jordan elimination method. And it relies on using a matrix to solve the system. So first we have to figure out what a matrix is and how we go from our system of equations to that matrix. So let's start off with the system. So the system of equations we're going to look at is 2x minus y is equal to 1. 3x plus 2y is equal to 12. So to take that system and write it into something that's called a matrix, we're basically just going to leave off the x and y and pick up just the coefficients and the constants. So this 2x minus y equals 1 would translate into a 2 for this 2, a -1 for the negative y, and a +1 for the constant on the other side. The second equation becomes my second row. I'll pick up the 3 as the coefficient on x, the 2 is the coefficient on y, and the 12 is the constant on the other side. Again, you do need to make sure that when you go from the system to the matrix, that you have the x's in the first column, the y's in the second column, and the constants in the third column. So, and then what we do is we put these brackets around it. We're gonna draw a line right there, and that line represents the placement of the equal sign in the original system. So we've gone from the system of equations with x's and y's into a matrix that we're going to learn to manipulate. So pretty straightforward. Our goal is to transform that matrix into this, a 1, a 0, and then there'll be a number over here. And again, the number is what's going to be our solution when we're all done. And then we're going to have a 0, a 1, and a different number. So number. So we're going to work on is taking the 2, the -1, the 3, and the 2 and making them into the 1, the 0, and the 1. This form over here is called the row reduced form. Reduced. So our first example is just going to come in and basically check to see if you recognize when the matrix has been row reduced or what that means. So example 1, we have part A, and it's simply the directions are asking indicate whether the matrix is in row reduced form. So we have a 1, a 0, a 3, and then we also have a 0, a 1, and a -2. So because we see our 1s on the diagonal and 0s in the other spots, and again, I'm talking about to the left of the bar that represents the equal sign, the answer is yes, this is in reduced form. And then just to take it a step further, we could also pick the answers back off of it. This top row is really saying 1x, no y is equal to 3. So the solution would just be the x equals 3. That's 1x equals 3. The bottom row is telling me that 1y is equal to -2. So once I've done my arithmetic and gotten it into this form, these are my answers sitting over here, which is why we like it, because they're answers. Okay, B on that one, again, it's just asking, is it in row reduced form? We have 0, 1, 4, and then we have 1, 0, 7. And I want to know if that's in row reduced form. Well, no, it is not. And the reason it's not is we need the ones to be on the main diagonal, top left to bottom right. So because these are 0s and not 1s, it's not in row reduced form. But of course, we want to be able to work with 3 equations and 3 unknowns. So let's take a look at a little bit larger one. So I have 1, 0, 0, 6. The next row is 0, 1, 0, negative 4. The next one is 0, 0, 1, 5. So is that one in row reduced form? Well, when you look at it, you see the ones on the diagonal, which is what we're after. You'll also see the zeros in the other non-diagonal spot. And again, the main diagonal is top left, bottom right. This one is in row reduced form. And it's a system of 3 equations because you can see the 3 rows sitting there. If we were to write the answer, we know that x would be 6, y would be a negative 4, and z equals 5. So the question becomes is how can we do this? Well, we have a handout that I've loaded onto the Blackboard for you that basically says, it's titled the Gauss-Jordan Elimination Method, and it tells you what you can do in order to row reduce things. So to summarize it, the arithmetic or mathematics that we can do to row reduce. And again, I'm going to put this into layman's terms, so we can do 3 different things. So these are the 3 things we can do. So I can, first of all, swap any 2 rows. So basically, I can take row 3 and write it as row 1, or I can write row 2 as row 3. I can take the entire row and switch it around because all I'm doing is rearranging the equation order. So that makes sense. You can also multiply any row by a non-zero constant. So that would be the same thing as taking your equation and multiplying it by 3, or taking your entire equation and multiplying it by a negative 2. You can also, if you need to, multiply it by a 1/2 or 1/3. You can also multiply, well, actually, you know what, let's write it in a little bit simpler terms. You can combine or add any 2 rows together. So we can add any 2 rows. Okay, so those are the things we can do. We can swap 2 rows. We can take a row and multiply it by a non-zero constant. We can also add any 2 rows together. And this is what we were doing when we were doing the elimination method. Didn't we multiply a row by something and then add the rows together? So it's the same thing we've been doing. It's just written a little bit differently. So then we're going to wrap up this part by just putting down some hints to help you get to the final answer. So these are my hints that are on my handout. Always work the columns. So these are just my hints. You want to work the column, but change the rows. Okay, what that means is you're going to try and get the column the way it needs to be with its 1s and its 0s. But to do that, you're switching the rows out. So I need to get the first column the way it's supposed to be. I'm going to get the next column the way it's supposed to be. But in order to do that, I'm going to be doing these manipulations with the rows. You need the 1 in the column first, in the column, before the zeros. And you'll see why as we do more and more examples of that. You get the 1 first, then you go for the zeros, and then when you go to the next column, you don't mess up anything by working with those zeros in the right spots. So, and then the last thing we're going to say is we usually 98% of the time, we multiply to get the 1 and combine rows to get the zeros. So if I'm trying to get the 1 in the column, I will come in and actually do a multiplication on that entire row. If I'm trying to get the 0 in that column, I'm going to add rows together to get to the 0. So that's the elimination method coming back. So that's our groundwork. In the next recording, we'll come and actually learn how to pivot.